Good morning. How are you doing today? I hope you're fine. It's good to have you, Ebuka, to the class for today. Like we mentioned, we are going to have a good time trying to understand the topic for today, which is our binary system of numbers. So this is what we are to discuss today. Binary system of numbers. So what do we mean when we say binary system of numbers? What are we talking about? Alright, so now before we even start talking about that, there is a system of numbers. A system of numbers, and you have so many numbers that obey that system. So it is our duty to explain it to you, and all you need to do is to pay rapt attention to understand exactly what we are expected to do and what you also expected to understand. Okay, so in system of numbers, we have different types. We have the decimal numbering system or the ternary numbering system. You also have the hexadecimal numbering system, and you have the binary numbering system. But let's look at the ternary numbering system or the decimal numbering system. So we have the decimal numbering system or the ternary system or base 10. So when you were in primary school, this was what you were introduced to. Every one of us passed through the ternary numbering system, the decimal numbering system, or the base 10 numbering system. But the difference is that we were not really told their names. We just came in and met this numbering system. It was a general thing. It was something that everybody is used to. So names were not given to them. But the actual fact is that this numbering system that we use has a name, and the name is ternary numbering system or numbers to base 10. Numbers to base 10. I also know that you can remember when it's said to have a unit, tenth, hundred, thousand, tens of thousands, hundreds of thousands, millions, place values. I know you remember. So those place values refer to your ternary numbering system or the base 10. So they follow that pattern, right? But now, to go a step further, the ternary system of numbers uses powers of 10. And when you speak of powers of 10, you are talking about 10 raised to power 1, 10 raised to power 2, 10 raised to power 3, 10 raised to power 4, like that. Now you know that 10 raised to power 1 is multiplying 10 times 10 raised to power 0. This will 10 times 10 raised to power 1. This one 10 times 10 times 10. This one 10 times 10 times 10 times 10. You see, these are known as your powers of 10. Now we know that in your indices, you see the powers there, the standard form of numbers. So you see the powers of 10 there. The first power of 10 for any standard number is 0. And anything raised to power 0, we know you actually have 1. We don't want to start going into details of that. We learned that during your indices. So 10 times 1, 10 raised to power 0 is 1. So 10 times 1 gives us 10. 10 times 10. Now, to make it easier for us, you know, I had taught you before that when you are multiplying with powers of 10, what do? You move the zeros to the right. Okay? You move the zeros to the right. So let's do that. So we just put 1 and add the number of zeros. You put 1, add 3 zeros. And you put 1, add 4 zeros. So it also plays out in it. As long as there's a number here and you have powers of 10, all you need to do is to add the number of zeros that you have. So this is what you have. So, and you also know when you talk about your units, tens, hundred, and thousand, and tens of thousands and all that. So here you have your tens, okay, hundreds, thousands, and tens of thousands. So this is what follows. This is what follows when you are talking about numbers that follow the decimal or the denary system of numbers. But this is just for the whole number part. This is just for the whole number part. But how about the fractional part? So any number you get, any natural number you get, so any natural number you get or any whole number you get falls under this system of numbers. Now for the fractional part, for example, let's look at the fractional part. So for the fractional part, you have 10 raised to power 1, 10 raised to power minus 2, 10 raised to power minus 3, 10 raised to power minus 4. And you know that according to your indices, this is 1 over 10, 1 over 10, 100, 1 over 1000, and 1 over 10,000. The difference is that you are having zeros. So you are having zeros in this manner. So what are you going to have? So just like you have 0.1, 0.01, 0.001, you have 0.0001. So it's still 4 zeros, including the whole number part. So that's the reason why when you are asked to convert decimals or fractional parts to standard form, you start counting the number of zeros so as to know the kind of power to use. Okay, so this is your denary system of numbers. So now let's find out, what if you want to find out those standard numbers? What if you want to find out those standard numbers? Let's give an example. So when you talk about place values of numbers, especially for whole numbers, then you are referring to the value of each digit in that number. Understanding this will help us to understand even your binary system of numbers, because each place value has powers of 10 attached to them. So for instance, what if you have something like this? Let's see the value of each digit, or the value of each digit in a number like this. So in a number like that, what do we have to do? Now this would, let's know the value of each digit inside 5431. Even from the spoken word, this has to be 5,000 plus 400 plus 30 plus 1 being your unit. Okay, or you can replace them as 5 times what? So this is your 10 raised to power 0, 10 raised to power 2, 10 raised to power 3, 10 raised to power 10 raised to power 2. Oh, sorry, 10 raised to power 0, 10 raised to power 1, power 2, power 3. So now 5 times 1000 plus 4 times 100 plus 3 times 10 plus 1 times 10 raised to power 0, or just say 1. So you see that you still get the same 5,000 plus 400 plus 30 plus 1, which will still give you 5431. Because we are dealing with powers of 10. Because we are dealing with powers of 10. That is the reason why during your expansion of binary systems, we say that base 10 you expand. For base 2 and any other base, you use your long division. Remember, what we are trying to do is to review some of these things that we have done before. You see that we expanded using powers of 10. Okay? Now, so that's how that is done. That's how that is done. So this is like a review of the denary system of numbers. So let's get on to the topic we have for today. So in the binary system of numbers, you are talking about the value of some numbers with regard to two numbers. That's why it's called binary. The value of a string of numbers for just two numbers. That's why it's called base 2 or binary. So let's imagine you have, so this is base 2 or power 2, or what you call zeros and ones. So let's imagine you have a string of numbers. Let's say, for example, you have, maybe you have 101, 001, 001, 111. You see that these numbers that you find here only appear in zeros and ones, right? You only appear in zeros and ones. So you want to identify base 2 in any place, they only appear in zeros and ones. And those zeros and ones are so important because in the digital systems, like in computers, you only talk about zeros and ones. In fact, when we were little, we were only told that the only language a computer understands, the only numbers a computer understands is just 0 and 1. And that is true, because in a digital system, meaning a system where you have your electronics, your gadgets working with the computer, the only language it understands is just 1 and 0. So any number that has 1 and 0s, we are talking about them as your base 2. Now notice that in our base 10 system, it is powers of what? 10. In base 2, it is powers of 2. Now, how do we know that? Take a look at this. So you have something like 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, and it just goes on and on like that. So powers of 2, right? Powers of 2. So if we convert them to base 10, if we convert these numbers to base 10, what do we have? So we have 1, 2, 4, 8, 16, 32, 64. I think we should have 1 here. 128, that is 2 raised to power 7, like that. So powers of 2. Powers of 2 alone, right? So any number you have, just like if this was base 10, you would have had what? 1, 10, 100, 1000, 10,000, 100,000, 1 million, tens of millions, and all that. So that is it. So it is different for base 2. So this is what you have. The difference is, instead of putting 10 here, we are putting what? 2. For instance, if I want to find 2 raised to power 2, it's just multiplying 2 twice. That's what the power means. Repeating the same multiplication for the same number 2 times. Alright? So now, this is what powers of 2 stand for. Okay? This is what it stands for. Now, let's look at how we can convert in a base 2 system. Alright? Borrowing a leaf from our base 10 system, let's look at how to convert in a base 2 system. So let's look at converting the following binary numbers to base 10. You have a particular system in mind. There's a pattern you always follow. But this is different. We are using tables now. We are using what? We are using tables now. So let's use tables the same way we are using tables for base 10. Let's use tables to find some of these things. So let's look at the first example that we have. Let's look at the first example that we have. Let's say we want to find something like 1101. Okay? 1101. So let's use the tables that we have. Now the first number for base 2, the first power of 2 is 2 raised to power 0, and this is what? 1. The second power of 2 is what? 2 raised to power 1, and this is what? 2. The third power of 2 is 2 raised to power 3, and that is what? 8. The fourth power of 2 is 2 raised to power 4, and that is what? 16. Now let's form a table with that. Now since we have formed a table, we are going to place, okay, since we have just 4 numbers, since we have just 4 numbers, let's not draw a table that is just too long. So we're just going to leave this like that. So now place these numbers here. You have 1, 0, 1, 1. Okay, 1, 0, 1, 1. So let's see. So what do we have? We have 1 times 16 put a bracket plus 1 times 8 put a bracket plus 0 times 2 put a bracket plus 1 times 1. Okay, are you seeing that? So we have 16 plus 8 plus 0 plus 1. So what is it in base 10? So 8 plus 1, 9. 9 plus 6 is 15. So you have 5, carry 1. So you have 25. So 25 base 10. Or even if you write just 25, it's like that. So you see how easy it is. If it was base 10, would have written 1, 10, 100, 1000, then multiply them. But this is different. It is base 2. Powers of 2. I want you to understand that. Powers of 2. So since they are powers of 2, this is 2 raised to power 0, 2 raised to power 1, 2 raised to power 3, 2 raised to power 4. Multiply them with the numbers you have under. It will give you your base 10. Okay? It's as simple as that. But now let's still look at that pattern that you usually follow. Let's look at the pattern that you usually follow. You can pause if you have not finished. Okay, you can just pause if you have not finished. But let's look at the pattern that you usually follow. Let's look at the pattern you usually follow. So let's look at that. You say 1, then you count, since you have 1 1 0 1, so you say you have 1 2 3 4. Okay, so you have, okay, so I just discovered a little mistake somewhere. We had here 2 raised to power 1 is 2, sorry, 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, and 2 raised to power 3, please, is 8. We didn't take note. We had written, I think, 16 or so. So you have 1 0 1 1, so which will give us 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. So that will give you 8 plus 4 plus 0 plus 1, which is 8 plus 4, 12 plus 1. So this is 13 base 10 as against the 25. Okay, so if you know your powers of bases like that, so this is what you have. The previous one, 25, was wrong. This is what you have. All right, so I was going to show you what you usually do. I was going to show you what you usually do when you say maybe if you have 1 1 0 1 like this, you now start saying 1 2 3 4. So you now say since you are working, since these are in base 2, you now say 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1, then times 2 raised to power 0. So you put them all in bracket. Then you have 8 plus 4 plus 0 plus 1. 2 times 0, 2 raised to power 0 is 1. So it's still the same 13 is 10. Okay, so you see, for both solutions you have what you have there. So it is not difficult. It is still the same pattern. It is still the same thing. But the reason why at times people get confused is, how did the 8 come there? How did the 2 come there? How did the 4 come there? How did the 16 come there? They are there because of the powers of 2 that you have. Okay, so let's look at a longer number. 1 1 1 0 0 0 1 1 1. Okay, it's a longer number. So let's use our powers of 2. Let's draw our table. Okay, so let's draw our table. So 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, right? 2 raised to power 1 is 2, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 2 raised to power 5, 2 raised to power 3 is 8, 2 raised to power 4 is 16, 2 raised to power 5 is 32, then 2 raised to power 6 is 64, 2 raised to power 7 is 128, 2 raised to power 8 is 256. Okay, so let's imagine we have such a table. Let's imagine you have such a table. So what are you going to do? So let's count how many things we have. I think we have 9. 1 2 3 4 5 6 7 8 9. So I think it's complete like that. So let's start attaching the base 2 number. 1 1 1 0 0 0 1 1 1. Now let's look at this. If it was the other pattern you were using, which is very beautiful, you are going to make sure that you identify all the numbers, but here it's not important, because these zeros, no matter what we do, we are still going to have zeros. So there's no need for that. So you only pick out the only ones that have ones in them. Pick out just those that have ones in them and identify them. So this becomes 256 times 1 plus 128 times 1 plus 64 times 1. There's no need for these ones, they are all zeros. If you add zeros to everything, you still get zeros. So don't add these ones that have zeros, leave them like that. Okay, so let's add this other, plus 4 times 1 plus 2 times 1 plus 1 times 1. See, it's important to add this 1 times 1 because it would surely change your values if you don't consider them. It will surely change your values if you say they are not important. So what do we have here? You have 256. My markers are fading, but that's not the problem. Plus 128 plus 64 plus 4 plus 2 plus 1. So let's add. You know, I like adding using place values. So let's add all the units together. So 1 plus 2, 3, 3 plus 4, 7, 7 plus 4, 11, 11 plus 8, 19. Are you confused? Okay, let's do it one more time. Let's start from the big number. 6 plus 8, 14, right? 14 plus 4, 18. 18 plus 4, 22. 22 plus 3 is 25. So we'll put our 5 and carry 2 to the tens. Okay? So 2 plus 5 is 7. 7 plus 2, 9. 9 plus 4, 13. No. Again, I've added 4 in the unit side. 7 plus 2 is 9. 9 plus 6 is 15. Okay, you carry 1 over to the 100 side. So 2 plus 1 is 3. 3 plus 1 is 4. So it is 455 in base 10. Are you saying that? It's actually very simple. It's not difficult, right? So converting the following binary numbers to base 10. So this is what you have. It's as easy as that. All right. But if you decide to use the other pattern where you have to identify all the digits, it's okay for you. But once you know the powers of 10, place your numbers under, then you get what you have. All right. Okay, so that's what we have. So let's look at the list of things that you are required to do. I saw this in what you sent me, so I'm going to just put it down. And I think the A is 110, the B is 1111, the C is 1001, the D is 1101, the E is 10001, the F you have 11011, the G you have 11111111, the H you have 111001, and the I you have 10101010. Then the J you have 11001101. Then you have your K 111000111. I think we have done this one. You have 1100110. So these were what you were given to do. So please, for these ones, you could use the tables to find them. All right. For these ones, you could use the tables to find them. Now, what I want us to touch a little aside from this is converting the base 10 to binary numbers. So converting the following base 10 or denary numbers to binary. So it's as simple as that. I think you've done this before. So let's take for example, you have, let's say, 9. Now the difference is that, just like I said, the only thing that you expand is your base 10. That's the only thing you expand. But if you are converting to any other base, you are going to use that base you are asked to convert. You are going to use the number, the particular number, to divide it. So you have, since you have 9, so we are going to use 2 to divide. Long division using long division. So 2 divide 9 will give you what? 4. Now the remainder, you put that remainder here. So 4 remainder 1. Are you saying that? It will give you 4 remainder 1, which is 8 remainder. So 2 here is 2 remainder 0, right? 2 here you have you have 1 remainder 0. 2 here. Now because you have gotten to the least, once you get to 1, even in other bases, once you get to 1, once you get to a factor here that is smaller than the base, you carry it over to, so you have 0 remainder 1. So what you do is pick the numbers upside down by going up this way instead of coming down. So you have 1001. So 1001. This is your base 2. So that becomes your answer. You have actually done it before. So let's look at a quite bigger number. Let's look at a quite bigger number. Let's say, according to the one you were given 84. So base 2. So 2, the usual division. So 2 into 8 is 4. 2 into 4 is 2. No remainder. So 2 into 4 is 2. 2 into 2 is 1. Still no remainder. But 2 into 1 is what? 2 into 2 is 1. 2 into 1, 0 remainder 1. Right? So you put that 1 over there. 2 into 10, 5 remainder 0. 2 into 5, 2 remainder 1. And 2 into 2, 1 remainder 0. And because you have gotten to the least, remainder 1. So it goes up this way. So what you have is 1 0 1 0 1 0 0. So 1 0 1 0 1 0 0. Your base 2. Alright. So I think that is as simple as that. As long as you are converting to base 2 or your binary. Okay. Alright, so let's also write out what you are being given so that you can use it. You can pause because I'm actually going to clean now. So what you are given, these are things that you are supposed to do. These are ones you are supposed to do. So let's look at them. So you have 8, your C you have 14, your D you have 17, your E you have 18, your F you have 30, your G you have 47, your H you have 52, your I you have 67, your J you have 84, which we have done before. So you have 200, and your K you have 500. Or you have to convert to base 10. Okay. All right. So that's all about bases. If there are any other discussions on any other topic, because remember we're still on proportions, and you were asking if we could make another video on the extra things on proportion, which I'll be doing by next class. But for now, get these ones done, and I think it has been a bit of clear explanation about how to solve bases, binaries, without your usual way, but using the tables to find them out easily. So I wish you all the best while solving the problems that you are given, and getting them across to the persons who need them, even to me too, if that is possible. So cheers, see you in the next class. Thank you.